for the next session. I didn't really know open source would be covered even in hardware. So here we have PCB Cupid, someone to bring the love of PCBs to you, Mr. Srinivasan and Mr. Harshit. And we have a little surprise for you. We're going to be giving you kits. We have a few limited kits, so maybe you'll have to team up. But I think it's going to be a really insightful session, and I hope you all are excited. Yes? No? I Alright. Well, if you're excited, you're going to get the kids, or I'm going to give them myself. So maybe get a little excitement going, and we have our speaker going here. We'll be distributing the kits to you guys shortly. But just one thing, they need the kits back you guys are done. It's not something that you can take home, but you have booths outside, and you can get things from them if you're interested.
So we intended this workshop for those kind of people. Okay? They haven't touched a wire, electronic chip, anything. They haven't done anything. So we want those software nerds to actually try out some new things. So we created this tank for these kind of people. So it's going to be very easy. Trust me, it's plug and play, and it's going to be fun. Yeah.
So I'll just give a very quick intro about what is PCB Cupid and what we are trying to do. So PCB Cupid is similar to, I don't know if you guys have ever heard about a company called Adafruit. So this Adafruit is a company which is based out of USA, and we are trying to replicate that in India. So basically we are trying to build open source hardware. So we make all these Lego blocks where you can put them together and build a product out of it, or at least the initial MVP that you want for your product. So one of the such devices is what we are trying to recreate here today. And apart from this, we have like a large number of SKUs and different products. And apart from this, there is one more thing that is called as circuit spell. So basically, circuit spell is a prompt to PCB design software. So basically, you can put up the prompt. Let's say ideally, in some situation, if you want to build a tank like this, right? You just put up the prompt that you want to build a tank. It will go through our catalog of products. Basically, everything is open source, and it will try to figure out what blocks you need to build the product. And it will put them together, and it will automatically do all the routing and everything, and you will get the final product. All you have to do is place order, and you ideally get something like this pre-manufactured in your hand. So you don't have to any soldering or any sort of things. It will be like plug and play directly. So this is what we are building. So the core concept is what are the modules we make, right? So everything is open source. In some case, let's say this is AI part is not something that you're interested. You can download it as a KiCad file. Again, this is open source, and then add more features to it, or reduce features, or modify however we need. So I think I'll hand over to Harshit and tell you what the tank is about and why did he come up with the idea.
Good morning. Good morning, everyone. My name is Harshit, and I am a 12th grade. I completed 12th grade recently. So when I was studying for my 12th grade exams, I was sitting on my desk, and I was getting bored. Honestly, I was studying for 2 hours continuously, and I couldn't come out of my study environment. Okay. So I'm like, I wanted to make something which could keep me entertained even while I was sitting on my desk. So I was thinking what we could do about that. So I was thinking something on the table which is small, which is plug and play, which is very easy to make, easy to use, and very fun as well. So I thought a lot about this. So my first design was just adding 2 motors and and wheels to it, and things that was really complicated again. So if we added 2 motors, then we need a motor driver, and then for the motor driver we again need a boost converter, and that again we need very big. So I want to make it something very small, like which could fit on your hand. So to make something like this, the solution I implemented was I used servo motors. So servo motors, they have a built-in motor driver within them. So you don't have to install an external motor driver for that. So what I did is I bought a normal 180-degree servo motor, and I opened it up and I modified it to make it 360 degrees. So what it does is, what servo motor actually is for is it is used for actuators and many other applications, but it can only perform for a set angle. Like you give it an angle and it goes to that angle. But you want it to be continuously moving. For something like this, you want the tank to be continuously moving. So for that, I have to open up the servo motor and remove the connector to the potentiometer and convert it to a 360 degree. So now it is able to make a full 360 degree rotation. So that is the first problem which I solved. The second one was, so we had two servo motors. Now we need four wheels for this to actually work. But then think about it. Two servo motors, it can only drive two wheels, and two wheels the maneuverability is not going to be that great. So I took inspiration from the tanks and I used the chain to link two wheels together so that they can have maneuverability in all the directions. So this chain is here. I got inspired by my cycle chain. Okay, I am a cyclist, so I got the design from cycle chain and I just made these sprockets and I fitted it together. So finally, the product is here. This is the T-01, the Explorer. So here it's a fully plug-and play. It uses the PCB Cupid Glyph C3 and their extension module, and it's like a Lego block. Now I'll show you how you can build it. It is very simple. There is no soldering required. Nothing. You just have to take the parts and plug them together, and you can have a tank ready, and you can play with it. That's about it. So this is my website. So here, what our intention is, what our main idea is to make hardware for people who don't know much very easy. So we try to create kits and parts which is very usable for beginners. So you can check out our website. This is the T-01 the Explorer. We have a kit as well, and we are planning for an ISRO moon rover kit as well.
Guys, just one more thing. Make sure you never connect the battery. So we will walk through the entire process and then finally after checking we will connect the battery. So it's very easy to try these things. So let's not connect the battery at any stage until the entire module is built.
So at any point, if you want to buy this tank, we'll have it on our website. We'll let you know soon. So for now, we are providing you with the kits we bought. So you can start working with that.
Okay. We have everybody needs to prepare.
Yeah. we only have 15. Yeah. We have only 15 boxes. So
People get like if you have friends, great time. If you don't have friends, make friends right now.
So by show of hands, can you let us know what is the count, like who is getting started in the electronics for the first time? That's it. Everybody have already used this code or something very similar.
no, who is like actually new to this hardware? Who don't know anything? Just raise your hands. Raise your hands. Who don't know anything? 30%. Did everyone get the kits? Whoever did not get the kit, raise his hand.
Okay, so I'll just give a very quick idea about how we come up with the architecture, right? Because since you are getting this for the electron for the first time, it's very difficult. How do you know what components you need to put them together? So the same thing goes for the software also, right? You need like multiple libraries put together that create a software. So the same thing goes here. But first you need to figure out, okay, what are those components? And it closely aligns with what are your goals. So let's walk through the steps and how do you figure out those components, and this is like a very small exercise, I'll just show you this. So let's say we have a very simple goal, as Arshit was explaining in the beginning, right? All you wanted to do was a very fun toy, which can move around and also have like a very cute eyes, which can do some random animations. So let's see, what are the components we might need to do that, okay? So one is, it should have some sort of control. Either it should have like a Wi-Fi control or Bluetooth control or some kind of communication for that. So let's have so that's one. And the second thing was the motor itself, right? So he was explaining a lot about the stepper motor, the servo motor. But I want to take it down even further. Why specifically they are using servo motor? And why not directly connect the random motors that we see to the controller? So every motor that you see, right, it has a magnetic field inside. And whenever there is a magnetic force, that's when the motor, whenever you energize it, the magnetic force gets converted into the mechanical force and it starts the motor rotating, right? Now the tricky part here is, each time the motor rotates, it also generates something called back EMF. So when this back EMF is generated, it might damage the controller itself. So that's why he used a term called motor driver in between. So the motor driver is what safely drives your motor without damaging the controller. So in terms of using a regular motor, you need another additional component called a motor driver. But this servo is something special. So this servo motor internally has a motor driver. And this motor driver can drive the servo in only, initially it can drive in only two directions, either left or right. And it has an angle control. So you can tell, go to 90 degree, just go to 90 degree. You say, go to 80 degree, go to 80, and 180 and 0. So that is how this stepper motor was meant for. But what we did was, last night we sat, we removed the motor, and we cut the communication so it doesn't do only 180. Now all the servos that you have, there is some sort of modification done. So it does the entire 360. So all it does is like, if you say front, it do clockwise, and if you say back, it does anti-clockwise. Okay. So that is the reason we are trying to avoid using the motor and go with the servo motor, so you don't need the motor drives. And then you need the OLED display itself. So I mean, you can do any sort of display, but the particular display that we use, right? It's called 1.3-inch SH1106 OLED display. So the specialty of this particular display is it requires only 4 pin for connection. So you can get different displays with a different number of communication protocol and different connections that you do to the controller itself. So the reason to choose this is it's very simple to use, and you can see 24 connection and it just plugs in place. And the most complex part about all of this is, right, you'll have another additional sheet like this. So this is the most complex part of the entire system. So this has a charge controller, basically a BMS, and also it has a boost converter. So I'll explain why we need a boost converter. So basically the battery that we use, right? So the battery is 3.7 volt. But all the servo motor or other motors, right, usually run at a much higher voltage. So it at least needs like 5 volt or above 5 volt. So what we do is we take this 3.3, it goes inside this sheet and converts it into 6 volt. So once you convert it into 6 volt, that will power only the servo motors. So we have divided the power and all the power management, all the complex stuff is handled on this board. So you don't have to do any of that. So I'll just click right now. So that is a servo sheet. So now if you see we have a controller with wireless, that is our lift board. You see it's based out of ESP32. And then we have the servo motors, and then we have OLED display, then we have a servo sheet, and then finally we have the battery itself. Yeah. Now you need to figure out how to put them together. So usually whenever we start something like this, right? So first we do something called prototyping. So basically you take only the controller, you power it on direct on your PC, and then you see whether the controller is working. So let's start with that. Just take the clipboard, and I hope you guys have seen C cable that you can connect your laptop. So any laptop charger or a mobile charger that would work. Just connect. I just want to show you how to test this and then go forward with the other components as well.
How many of you have cables and how many of you don't show your hands?
Cable, C type.
I don't have. No one like your team has it. Maybe if someone has two in a team, you can like pass it over. Does anyone have two in a team?
I have one.
Yeah.
Yeah, you just you don't need for the whole session. Just for quick testing, and also only to upload the code once, and then it will be completely independent. You don't need to enable all this.
So we can like do it, and after you're done, maybe you can pass it to the teams who don't have it, and we'll repeat if you guys like, get stuck in it. Will not be able.
So, and how many of you are using Mac? No Mac, right? Only one? Okay. So for Windows, I think Mac is even more straightforward. For Windows, you can just go to Device Manager. And you can see this bunch of codes opens up. For some people, might not show up any port, but for some of you, can have some default ports. And once you connect this clipboard, right? You can see there is a new port that shows up called USB serial device. So just quickly check if that shows up. Who needs cable here? One cable. Everyone else has a cable. Yeah, just make sure that the port is working. So we know that the controller itself is working. For Mac, you can do LS USB and you find the terminal. Just make sure for the command LS USB.
Does anyone have any questions? Do you need us to repeat something? Everyone said consent.
You have a question?
Just few minutes.
This is fast. So, so the second step would be like take your servo sheet, and you can see it's like a shield. So you can just press it on top of it. Make sure all the pins align on both the sides. There's 12 on one side and there's 16 on the other side. So make sure that it just fits like a sandwich.
So, is everyone done with the first few steps? Okay, explain on how to connect to your computer and configure stuff. So, is everyone done? If you guys need any help, you can come over. So we'll be continuing. So, the next thing is, how did we actually design these parts? Like you see the 3D printed parts. So this is one of the most important step I'd say for prototyping stuff design. So what I use is SolidWorks. So these are CAD software, computer aided design. So you can design stuff on your computer. Okay. Few many years ago, around 50 years ago, they used to do all of these things manually on paper. But now we got softwares to actually do this stuff. So right now I use SolidWorks. You can use, there are many out there actually, free ones as well. You can explore them. So these are my models. Like, yeah, so I don't have a mouse here, I can't actually pan it to show you. But yeah, you get the idea, this is how it looks like. Okay. After I do this, to print it, I use, I have a printer at home. So I have a slicer software here. I just click on slice plate and then print. So this is how we actually made the hardware stuff. These chains, these all the plastic components. So coming to the servo motors, I'll actually. Oh, yeah, I actually. Okay. So coming to the servo motors. So all of you know, like if you connect the motor to a battery, it starts spinning, right? And if you reverse the polarity, it spins the opposite direction. But how do you actually control its speed and where it stops and stuff? So that's when a microcontroller comes in. But you can't connect it directly to a microcontroller because there are signal pins which only operate at 3.3 volts, I guess, right? Yeah. So for that we need a motor driver, again we told. But now adding a motor driver makes things very complex. We need more wiring and it increases the size. So that's why we use a modified servo motor. So if you can see inside, this is a green color chip. So this is what is actually controlling the servo motor. And there is a motor here. This is the motor. So what we did is, there is a potentiometer here. So the potentiometer, when it moves, the resistance changes. So according to the resistance, the microcontroller knows that what position it is supposed to set it at. So now, if we completely block off all the links to this potentiometer, so like, I can't remove this, but so there is actually a plastic piece which screws into the potentiometer. So that's how it knows like which angle it is positioned at. So we cut that off and now it is a 360 degree servo motor. So you can control the speed. Like if you now you program the servo motor to actually move it to angles. Like 20 degree, it moves to 20 degree angle. If you want it to move to minus 70 degree, it moves to 70 degree angle. So that's how it works. But we disconnected the potentiometer. So now you ask it to move 20 degrees. It actually moves continuously on say clockwise. And if you say minus 20 degrees, it moves the other way, anti-clockwise. So that's how this works. So that is about the 3D printing. What else? Okay, yeah. So you have the board here, right? So this is the main board, PCB qubits. This is the glyph C3 and this is the extension module. So as of now, all the teams should have been able to do this much. So can I get a yes if everyone has done till here? Okay, yeah.
There's a reason why I asked you to put this first, but again we have to remove it. Just to make sure nothing fries up, again you connect the USB and make sure there is no sort of disruptions. There is no heat anywhere. And also there's a light under. Make sure all the lights are lighting up. That's it. There are two lights. One is under and one is above. So just make sure both of them are working. So the under one might be a little faded, but still there will be under one and there will be a on the top one. Any issues? Anybody facing any issues with the boards? So everybody set. We'll go to the next step.
Next step. So yeah. So this is the base of our tank. So this part is what holds the servo motors. So this is very simple. You actually might have already figured it out. So what you do is you take the servo motor, you hold this part and you push it through this hole right here. So this is how it should look like. The wires should go through this hole like this from the inside. Is everyone able to do this? Yeah. So do the same for the other servo motor as well. So you should have something looking like this. After that, you pull the wires and you make them sit inside the case like this. Do the same for the other as well. So finally, the assembled servo motor with the case should look like this. Okay, I want everyone to finish until here. If any questions or any problems, like you can call me. I'll come over to your place. So everyone is clear? Clear? Huh? Oh, they got it. So, assuming everyone has completed this step, let's move on to the second step, which is actually placing these wheels. So again, if you see on if you have ever looked at a cycle, they have these sprockets which are designed similar to this. So I took the inspiration from that and designed this. So what you have to do is the ones which have smaller holes in them, you directly plug them into the servo motors like this, and it should snap it. Do the same for the other side. So it should look like this. So coming to the next step, you take a chain, you put them around like this. And then you take the small piece over here and the wheel. So you want to insert this into the chain and onto this mount here. So ideally it should look something like this.
Yeah, it just happened.
Yeah. So then you take this and then you plug it in. So it should look like this. So and repeat the same for the other side. So put the chain, take the bracket, okay. So has everyone finished until here? It should look something like this. Can I get a thumbs up?
Does anyone have any questions? Sure. Or everyone's caught up?
So actually, there are 15 links in the chain. So you guys can see this chain right here. It has 15 links. Okay, and because of the 3D printing tolerance issues, it's actually very small for it to actually work properly. So to solve that issue, you guys should ideally add one more link. So what you can do is you can remove this, remove the chain, and we'll be we'll be providing you with extra links. So you take this link and then you push it in, like this. Right. Oh yeah. So you take this link and you push it in like this. So it should look like this. Yes. I'll give this. Yeah, correct. Two links, right? If you guys are facing any issues, you can just raise your hand. I'll come over to your place. Excuse me. You guys want this? You just joined. Okay. Yeah, you can take it. You can build it. We have started building it. We have gone through the first few steps. You can catch up. So. So, this is the next step. So once you have this setup ready, right? Is anybody still doing this here? Do you need any help with this here? Raise your hands. This is boost and boost with accuracy and it provides so, if you want, right? This is any next one. This is very favorable. So given this, having the actually experience, second someone. Yes.
Okay. So this is the next part. You can see this is the top, and it has 4 helium cells. So this is the most tricky part, and it's very fragile. So be very careful how to use this, because the flaps you can see, right? So the flaps can break very easily. So we just make sure the flap is not breaking. So
Yes. Yeah, sure. So you see these two links here. What you are supposed to do is you have to push it to these two gaps here. So it ideally goes like this.
very small amount of flex, and then you just push it straight down.
You push it straight on. Be very careful with this. It might break. Yeah, and we have very few replacements for them. So try not to break it. So after you like write the thing, you just write so if you guys are facing an issue, you should have something like this. And if it broke, we have very less replacements. Try not to break it. Did you break it? Okay, okay.
பேசவே நல்லா எவங்களும் இல்லையா அங்கே அவங்க கனெக்ட் பண்ணியிருக்காங்க உங்களுக்கு முடிஞ்சு ரெக்கார்ட் ஆஃப் பண்ணியிருக்காங்க
Assuming everyone is done, let's proceed to the next step.
Does anyone have any questions? Does anyone start on any step? No? All good?
So the next step would be the battery. So this is a little tricky part. So not everybody has the same battery. So the length is same, but the thickness is varying for some people. So some of you might have it a bit thicker, and some of you might have it flat. So if you place it right, so you need to place it. So you did this servos right. If you notice, one servo is longer than the other servo. So when you're placing the battery, the wire should be on the shorter side of the servo. This way, you can see the shorter servo wire is this way, and the wire is also in the same direction.
Any confusion here?
It's fine, like some of you have a different battery. So when we add this on the top, right, so that will hold the battery.
Camera on ya.
So on some of your batteries, there is a sticker behind your battery tip. So this is it would be a double-sided tip. On this battery, there is nothing. Yeah, this one has it. So there's a sticker here. Here. So this is actually a double-sided tape. You can actually use this to stick it onto the tag. This is totally optional. If you want to do it, you can do it.
You just have to force this. So it fits yeah, that's so then I got next to because the dimension.
So has everyone attached the battery? Can I get a thumbs up? Yeah. Okay, so the next step would be actually to remove this. So you guys remove it again. Yeah. So you take the glyph C3, it looks like this, and you place it onto the tank.
Yeah. Whichever the battery direction, right? The C type should be on the direction of the battery connector. So the battery connector is here. The C type is on the same direction, and you have to put it together. So we pass a screwdriver. You don't have to.
So you have a screwdriver here, and if anyone wants to use it, just raise your hands. It will be turnwise.
And one, two. You don't have to screw all four in. You can just do like any two corners. That should be fine. And people when think of batteries, right?
Direct VSS.
That's what. So basically, if you try to screw it in too hard, so it is going to dig through the battery itself. So make sure you just do it to half support, not exactly over the entire stuff.
So if you accidentally puncture your battery, you might actually start a fire. So let's not do that. Okay? So just tighten it very tightly. Don't actually push it in fully. So it should look like this, okay? Don't push it in fully, okay? The battery is here. Try not to puncture it here, okay? Yeah. So I'm passing on the screwdriver. You have to screw down any two corners. Like for example, we did it here, this and this corner. You can do any of the corners. So I'm passing on the screwdriver. So first. Any two you can do. Guys, is everyone done? Oh no, you can't do that. Like if you guys have any screwdrivers, you can use that and you can pass that on as well. Yeah, pass it on.
Saja.
So after you're done screwing, it should look like this.
ಯಾರು ಬೇಕು
Oh, what's the
அதான் சரி பாட்டு போட
இன்னும் கொஞ்சம் வந்துக்கோங்க.
Yeah.
Okay, so how was the session so far? You guys have fun? Did you learn more about hardware? For like the newbies, the people who like touched hardware the first time, what do you think? Okay. Yeah. So, how many of you are done with the screw driving? 1, 2. Okay. And how many of you are left? How many teams are left or everyone's done?
That was last game. For screwing, right?
Yeah.
Yeah, that was last game. So, coming to the next step, so you should have your tanks looking like this. Everyone's tank is like that? Yeah. So then, we mount the shield. We mount the shield onto this board. So you have to align the pins, be very careful, and so you should ideally mount it like this. So your tank should look like this. So everyone's done with this step? Thumbs up? Yeah. Okay. So coming to the next step, okay. Don't connect the battery, okay. You might burn it. Don't connect the battery. We'll tell you when to connect the battery. Keep that for the last. So next step is, you see these two wires here? So these are the servo connectors, okay. They connect the servos to the board. These. So you should see two L-shaped pins here. So the L-shaped pins are right here. So you take the smaller one and make sure that the yellow wire, it should be facing outward, like this. And you connect it like this. So make a note, everyone, because if you do this step wrong, you might actually burn the servos. Make sure the yellow wire is facing outward. Yeah. So you see these labels here, S1, S2, S3, S4. So the yellow wire should be facing towards that.
Is everyone with us so far or repeat?
Do you want me to repeat it? No, it doesn't. Go check.
Can you repeat it?
Yeah, sure. So there are two wires here, the front servo and the back servo. You have to take the shorter wire and you have to connect it to the bottom L-shaped pin, right here, the bottom. And you have to make sure the yellow pin is
Sorry. Which team has a screwdriver?
So has everyone understood this step? Because this step is the most important. Do the same for the longer servo wire, which should go on top of this. So you pass it through the hole here. And you can see you pass it through this hole, and you get the wire from the other side. Should be like this. And then you connect it to the top L shape. Again, you have to make sure the yellow wire is facing towards the labeled pins here, S1, S2, S3.
Okay. Show of hands. How many got that? How many didn't get that and want to repeat? Or
Yeah, yellow wire.
It needs to face towards S1, S2.
Yes. So has everyone done this step? It should face the.
This was just to reduce the angle should be at the
So has everyone completed this step? Can I get a thumbs up?
does anyone need help? Yes.
Yeah, this session is going great then. Okay. So the next step, the most important step. Okay. So next step is to connect the OLED display. You have this black color display here, the screen. So you take the screen and you place it onto these 4 pins here. So there is a 4-pin connector placed behind the board here, and you have to align it to these 4 pins and connect it. So should mount onto it like this. So it should be like this. So this is, has everyone completed this step? Yes? Okay. So, okay. The most important step, okay. Again, make sure the yellow wires, you see here, it should be towards the labeled pencil. S1, S2, S3. If you don't do this, the thing is going to burn. So, I'll come over to each one of you and I'll ensure that you have done this step correctly because we don't want the server to burn. Okay? Yeah, I think you're doing it. So, guys, everyone are done. I'm assuming I've come to your place and checked. So, moving to the next step. The next step is actually programming the chip to actually perform this function. So, what we're using is we're using the Arduino IDE. Yeah.
So for this particular programming, right, it's already written. It's on his GitHub.
So, everyone of you. So every one of you go to our GitHub. It is a Vibit. Go to our organization and go to repositories and click on T-01 the Explorer. And after that, you will see a file named workshop. You have to click on that file. Have everyone found this page? So this is the link. Yeah, this is the link. Go to this link. So all of you have Arduino IDs.
So the initial idea was we'll just share you the bin file, and we have a software called ESP Flasher. So basically, you take the bin file to the ESP Flasher and you can just burn it directly. You don't have to code, you don't have to compile or anything. But we just figured out there is a technical glitch over there. So even if you share the file, right, now when you turn it on, everybody will have the same AP. So it will just be spamming the same AP across every one of you. So some of you already have a Arduino IDE. So you can just download this, copy paste the code and compile it. If not, you just get the laptop, everything is compiled. We'll just change the AP for all of you and we'll just try flashing it to the boards. So that way it will be much easier. And I guess there's not a lot of people. Each flashing will take hardly like 30 seconds. So we'll do that process.
Yeah. So everyone who doesn't have Arduino ID, raise your hands. Yeah. Okay, fine. So
We'll start from here.
So for those who have the Arduino ID, they can do it by themselves. So you see the USB-C port here. You want to connect this to your laptop, like this. So you should have an empty sketch like this, like that. So the first few steps, what you have to do is you have to go to board selection. You have to click on this drop-down box here. You will see in any of your comp, you will see ESP32 family device. So you go and click on select other board and port. So you should search for the glyph C3. This one. You select this one and you select the comp, whichever comp. So it should have USB here. So if you don't have any other USB devices connected, you can automatically assume that this is the port and you can click on this. And click on OK. So you should, if you see this, you have done the step correctly.
Anyone who wants to repeat this? You repeat this again.
Yeah.
Clip C3.
So after everyone is done with that, go to our GitHub, workshop, and copy paste the entire code onto the Arduino ID. So you should have something like this. So for those who are doing this by yourselves, you can change the SSID to whatever name you like, because we don't want it to be common. You can find yourself a unique name for your bot and you can name it yourself. So after you're done with everything, you should just click on upload. This one. You should be doing all of these steps while your tank is connected to the laptop. Yeah. So after the code is uploaded, you should have something like this. You should have the OLED display with the eyes, and you should. Okay, you guys, you see the wheels are moving. Ideally, they should not move. Okay, but if you want to fix this, we have an issue. We have a way to fix this. So you go here, and we have defined two things here: the left neutral and the right neutral. So these are set to 1500. So you have to manually adjust this to get stationary servo motor. So. So if you guys want to do it, you can do it. We're not going to brief you through how we are actually doing it. But if you guys want, you can try changing these values. I'll just give you a very brief explanation. So assume the left neutral is for the left servo motor. So if the left servo motor is moving forward, then you want to decrease this to some value. Let's say 1450, something like that. And you keep increasing / decreasing to until you get your servo motor like stationary. So yeah, that is up to you guys. We are not going to doubt. Yeah. Then you have to update your Arduino ID to the. So you have to go to OS Manager here and you have to install ESP by Expressives.
So now for the functionality, right? Once the code is uploaded, what to do with this? You just connect this battery. You can see it starts working. And yeah, this might happen. So this is due to like a low battery voltage or something, where the servo is not continuously rotating. Yeah, this one. So when you connect your, we can say it will be back to fully functional, and it will create a hotspot. So if you open your phone or even laptop, just show it in the laptop. Yeah. So whatever the name you have given for your tank, right? That tank name will show up.
Oh yeah, that's it. So you go to your Wi-Fi setting here. So I have named my tank T-01. So you should find this here. Whatever you have named your tank, you connect to that network. The default password is 12345678. So this is the password. Just connect it. So after this, on your Arduino IDE, you should do Control Shift plus M.
That should open.
That should open the serial monitor. So here you will get an IP address here. So what you have to do is you have to copy paste this onto your browser. Yeah. So after you enter the IP address, you should get a web UI to control the tank. So So as you can see, this is the tank UI we made here. This is very simple. Yeah.
And you have left. And you have left. And the stop should ideally make it stop, but he was explaining about the calibration, right? So just because of the calibration, it won't stop, but it will be like very slowly spinning. So once you do the calibration, it will be in complete ideal position, and then you can do back, front, and left and right. And the charge is also another important thing. So the battery has to be fully charged. So some of your products might work out of the box, but some of you might have to connect the USB for quite some time until the battery is fully charged. Yeah. So that's how it works. And we'll try to upload the code for some of the other people. And whoever has the Arduino IDE, right, you can either try doing the calibration or you can just upload the existing code. Yeah. Done. Any questions?
yes. So you wanted to know the how to do it. Yeah. So how the servo motor works is, as I told, it has a potentiometer inside. So the potentiometer is set at a point. So it has a resistive value, like so it is a knob, okay. And if you turn the knob clockwise, the resistance increases. If you turn it anti-clockwise, the resistance increases. That's how you actually control the servo motor. Now we disconnected the potentiometer. So while disconnecting the potentiometer, if we did not actually center the potentiometer correctly, that's when this issues come. So not all servo motors are ideally in the center position. So that's why you have to tweak it in the code. Yes, yes. So you actually find readily available 360-degree servo motors. They're slightly more expensive. For this workshop, so because we're on a budget, we got normal. Yes. PCB Qubits board. I think it will be available on shop in a few days. So I think you can connect up to 6 servos onto that. Yeah. For this tank, we are using only 2. Yeah, we have to solder more pins and you can add more servos.
அவங்க காட்ட சொல்லிட்டு போனாங்க. அவங்க காட்ட சொன்னாங்க. நம்ம காலையில் வந்தோடனே நானும் கொஞ்சம் கொஞ்சமாக அப்படி காமிச்சிட்டு
Excuse me, what would you name your tag? Like, you can name it anything. Anything?
இப்படி போச்சுன்னா எனக்கு ஒரு டோட் இது இங்கிலீஷ் இருக்குது அப்படியே வந்து இந்த பேக்கில் அது மாதிரி வீடியோ குவாலிட்டி நல்லா இருக்காது.
முடிஞ்ச வந்து
அதுவே மாறிடும்.
கட் பண்ணிவிட்டு கடை முடிஞ்ச இப்போ லஞ்ச் ஹவுஸ் இல்லை கட் பண்ணிட்டு போதும் 28 எவ்வளோ போதும் முன்னாடி கிளிப்படி வேறு டெலீட் பண்ணணும்.
எந்த
இது பார்வன் படம் தான் ஓடிட்டு.
ஆனால் இது பார்வன் புது கார்டு தான் நினைக்கிறேன். பாப்பா எப்படி இருக்கு
தமிழில் லைவ்
லைட்டாக இதாக இருக்குங்க. இந்த சைடு கொஞ்சம் இறங்கி இருக்குங்க பேருக்கு. லைட்டாக இந்த சைடு இறங்கிருக்கு, கொஞ்சம் கொஞ்சம் அதிகமாக இருக்குதுன்னு. போட்டால் வந்துடும். எனக்கு எதுவும் வருவேன் ஒரு ஒழுங்காக கொடுத்தீங்கன்னா மொத்தமாக
ஏன் பவர் கேப்
பவர் கேப் நாங்கள் இருக்கு இப்பயே எடுக்குன்னீங்களே போதும்.
பவர் கேப்
அது அந்த எஃபெக்ட் லெவல்ன்றது
அதையும் பார்க்கணும்.
அதில் எப்பவுமே செக் பண்ணணும்னா அதனால் அது உங்களை செக் பண்ணுவாங்க. அந்த 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 எஃபெக்ட்
பேக் எடுத்து வைக்கும்போது எல்லாம் கரெக்டாக இருக்கான்னு செக் பண்ணுவாங்க.
இந்த எஃபெக்ட் இருந்திருக்கு, இதில் இல்லை.
இல்லைன்றதை பற்றி தான் பேசுகிறேன். இருக்குன்றதை பற்றி பேசுகிறேன். மண்டியா நீங்கள் 2 பேரும் தான் தேடி பண்ணிக்கிறேன்.
இது காட்டுறா, இது காட்டுறா.
நாங்கள் எதுக்கு பேசுகிறது அவசியம் இல்லை.
Whose tag is this? Raise your hand. Right. QWR.
So all of these. Okay. No, not only the Wi-Fi. Only from this. This only this. These three are built in. So we do get this. You can get it from our GitHub. So what do you want me to give you? Anything? It is compatible. I could use C, but again, for that compiling it, C. You know what they have done is they have made compiling very big. If you want to use C, you have to actually know a lot of stuff. So, got it. Yes, sir. Yes, okay, I think. Yes. Okay. So as you told, all the wires. So. Only one cover means the other one is damaged. Can you by mistakenly switch the thing? Okay, then we'll have to replace that. Yeah, you can replace So guys, so here is my controller. So you can actually get yourself one. We're going to be launching them next month. So yeah, this is my controller. I made this for myself. We'll not be selling this. We'll be selling a smaller one of this. So you could actually connect it to your, your tank, and you can control it. Yeah. So it works like this. So we couldn't get you the controllers for this workshop because it was already too many components. So if you guys want to get this controller, it will be on site next month. So if you guys want to try this out, you can come here and any one of you if you want. Yeah. Come.